Hello everyone. In previous sessions, we have done right from definitions and properties to some illustrations on inverse trigonometric functions. And we realize that they may not be sufficient. So I come in this session again with some more illustrations on inverse trigonometric functions. Now I take the first one, and the first one is that we have to show whenever x is between 0 and 1, sine inverse x can be written in terms of cos inverse, tan inverse, sec inverse, cot inverse, and cosec inverse. Now, if you wish, you can remember them as formulae, provided you remember the condition that x lies between 0 and 1. Then only these, like sine inverse x equal to cos inverse under root 1 minus x square, etc., they would make sense. I hope you understand what I mean. Condition is important. As I have been saying in my previous sessions also, inverse trigonometric function, this topic is extremely sensitive. So you have to be careful about the conditions also. So if I have to start, what I remember or what I keep in my mind is the condition that x lies between 0 and 1. And I would name that theta equal to sine inverse x. Mind you, please, I never start with x equal to sine theta. I would start with theta equal to sine inverse x. And that condition that x lies between 0 and 1 would lead to that theta has to be now between 0 and pi by 2. That means you are in the first quadrant. You are talking about the first quadrant part. Fine. Now theta equal to sine inverse x, if I take sine on both sides, would lead to x equal to sine theta. Now I have x equal to sine theta with me, and now I have to write answers for I have to get answers for cos inverse of something, sec inverse of something, tan inverse of something, and hence I go for first cos square theta, which is 1 minus x square. Then from here I write cos theta, which is under root 1 minus x square. And I am so tempted that I will be taking now cos inverse on both sides. And I take cos inverse also as I decided. And I write cos inverse of under root 1 minus x square equal to cos inverse of cos theta. Now tell me that will I be writing this straight away as theta? Can I do that? I will have to check where does theta lie. It has to be in the range of cos inverse. And in the previous step, I have written theta lies in 0 to pi by 2. And 0 to pi by 2, this interval is in the range of cos inverse. What is range of cos inverse? 0 to pi. So it is very well within the range. And hence, I can write theta equal to cos inverse of under root 1 minus x square. And mind you, please, which is given at the top on the left hand side, the leftmost expression is sine inverse x. And that is nothing but theta. That means I have shown sine inverse x equal to cos inverse of under root 1 minus x square. Now, if I have to attempt next for say tan inverse or sec inverse or cot inverse, don't you think we will have to use whatever properties you have done, basic trigonometric identities in trigonometry? And from there, I will be writing, now for say cosec, I have to use the condition that x equal to sine theta. So cosec theta is 1 upon x. I would be taking cosec inverse on both sides, which is very, very tempting as I said before. So cosec inverse of cosec theta equal to cosec inverse of 1 by x. Now, before writing this as theta, make sure that theta is in the range of cosec inverse, and it is in the range of cosec inverse, and hence I can write theta equal to cosec inverse of 1 by x. And what is theta? Theta is nothing but sine inverse x. So we have proven sine inverse x equal to cosec inverse of 1 by x. Now, what could be my next attempt? Suppose I have to go for cot. I make use of this cosec square theta, which is 1 by x square. And from here, I try to write cot square theta. How do I write straight away? I hope you all remember. 1 plus cot square theta is cosec square theta. So from there, I can write cot square theta. And it turns out to be 1 minus x square upon x square. Go for cot theta. And I pick up the positive square root. Why do I do so? Because theta is in 0 to pi by 2. I'm free to do that. Because cot theta is basically positive. Then I will be writing theta equal to cot inverse of under root 1 minus x square upon x. I have written that step straight away. I hope everybody understands what I have done. You take cot inverse on both sides. It means cot inverse of cot theta actually. And cot inverse of cot theta is theta provided theta is in the range of cot inverse. And theta is in 0 to pi by 2. So it is well within the range of cot inverse. And that is why straight away I have written theta equal to cot inverse of under root 1 minus x square upon x. Now tan theta. since I have with me cot theta, I can write tan theta. Tan theta equal to x upon under root 1 minus x square. I take tan inverse on both sides, and then I may write tan inverse tan theta equal to tan inverse of x upon under root 1 minus x square. I would replace that tan inverse of tan theta as theta because theta is in the range of tan inverse, and hence theta equal to tan inverse of x upon under root 1 minus x square. And mind you, please, I have written theta equal to cosec inverse of something. I have written theta equal to cot inverse of something. Theta equal to tan inverse of something. What is theta? Theta is actually sine inverse x. So see at the top, we have got result for sine inverse x equal to, in terms of tan inverse, we have got in terms of cot inverse, we have got in terms of cosec inverse and cos inverse. So what is left out now? Now sec. So we go for sec square theta first. If you wish, you can do that. Sec square theta, if I have to write, I can use 1 plus tan square theta, or I can write straight away from cos also. Cos theta was under root 1 minus x square. So sec theta is 1 upon under root 1 minus x square. And that would lead to, if I take sec inverse on both sides, sec inverse sec theta equal to sec inverse of 1 upon under root 1 minus x square. Correct? And that gives me theta equal to sec inverse of 1 upon under root 1 minus x square. So we have actually done all one by one. We were quite safe and we were easily proceeding because 0 to pi by 2, this interval lies in the range of every inverse trigonometric function appearing there. That is why our proceeding was so easy or so smooth. Now let us move to the next one. And the next one also could be quite similar to this, where x is between 0 and 1. And now we try to write cos inverse x equal to, and in terms of other inverse trigonometric function we have to show. Okay, how do I start? Exactly on the previous lines, that I may start with naming cos inverse x, and I write that as theta. Condition 0 to 1 leads to theta in 0 to pi by 2. Now you know what I am thinking, that instead of taking the previous approach, can I change my approach? I mean, I'm just giving you some another approach so that you keep your mind open and you may think on your own lines also in future. What I'm thinking, when theta is between 0 to pi by 2, can't I use basic right triangle approach? Yes, actually you can. I am given theta equal to cos inverse x. So from here, if I want to write x equal to cos theta, then how would I write? How would I proceed from here? That I get that x equal to cos theta leads to this triangle kind of thing, where your perpendicular I have shown as under root 1 minus x square, base would be x, hypotenuse is 1, and from there I start writing. What is sine theta? Sine theta would be under root 1 minus x square upon 1, correct? So theta, if I want to write from there, I will take sine inverse on both sides. So sine inverse sine theta equal to sine inverse of under root 1 minus x square. Sine inverse sine theta I can write as theta, mind you please. So theta is nothing but cos inverse. So we have arrived at the answer that cos inverse x is sine inverse under root 1 minus x square. Now I go for tan theta from the triangle only, and I write tan theta as under root 1 minus x square upon x. Take tan inverse on both sides, and that would lead to tan inverse of under root 1 minus x square upon x. And I'm writing that for theta. Tan inverse tan theta is theta, and theta is nothing but cos inverse. So we have shown relation between cos inverse and tan inverse now. I can go for cot theta. Just take reciprocal of tan theta. That is x upon under root 1 minus x square. From there, I take cot inverse on both sides. Cot inverse cot theta, I will be writing as theta because theta is in the range of cot inverse. And similarly, I proceed for sec also. And sec theta equal to 1 by x would lead to sec inverse 1 by x equal to theta. And theta is nothing but again cos inverse x. And cosec theta is 1 upon sine theta. So from there, I can write 1 upon under root 1 minus x square. I take cosec inverse on both sides. And finally, I get that as cosec inverse of 1 upon under root 1 minus x square. So we have got sine theta, tan theta, sec theta, cosec theta. And from there, we have actually got the answers in terms of sine inverse, tan inverse, cot inverse, sec inverse, and cosec inverse. And that is what we wanted. Look at the top, correct? So my question gets over here. Now, let us move and get one more and try that. Now, that says that if x is between 0 and 1, I try to write now tan inverse x in terms of sine inverse, cos inverse, cot inverse, sec inverse, and cosec inverse. Now, what could be my procedure? What do you think? That again, similarly, we should start that x is between 0 and 1. I can name tan inverse x as theta, true. and from there I will be getting condition on theta. So theta is between, since 0 to pi by 4, I go for right triangle approach also. Frankly speaking, whenever theta is between 0 and pi by 2, right triangle approach is any time welcome. So I go for this problem also with right triangle approach, and then one by one I will start writing. Reason? Because our angle is between 0 and pi by 2. In fact, here more precise, it is between 0 and pi by 4. I go for x equal to tan theta, and from there I start writing. My sine theta from the triangle is x upon under root 1 plus x square. Sine inverse of sine theta I will take. That means on both sides I will be taking sine inverse. It is sine inverse of x upon under root 1 plus x square. Now left hand side sine inverse of sine theta would become simply theta. Reason? Theta, which belongs to 0 to pi by 4 in this problem, is well within the range of sine inverse. Now I go for cos theta. Cos theta is 1 upon under root 1 plus x square. From the triangle I am saying. And take cos inverse on both sides. That would lead to theta equal to cos inverse of 1 upon under root 1 plus x square. I am straight away saying theta equal to. In my mind, I have already done cos inverse cos theta is theta, provided theta is in the range of cos inverse, which is true in our case. Now I go for sec theta. Sec theta is just reciprocal of cos theta. So it is under root 1 plus x square. Or you can write from the triangle also. Sec inverse I will take on both sides, and I get theta equal to sec inverse of under root 1 plus x square. I go for cot theta. Cot theta is 1 upon x, correct? From the triangle I am saying. Cot inverse I take on both sides. So I get theta equal to cot inverse 1 by x. And cosec theta when I write, I get cosec theta is reciprocal of sine theta. So cosec theta would be under root 1 plus x square upon x. Then take cosec inverse on both sides, and that leads to cosec inverse under root 1 plus x square upon x. Now I have done sine, I have done cos, I have done sec, cot, cosec, and we were given tan. So all are done. So we have established relations between tan inverse and sine inverse, tan inverse and cos inverse, etc. So all 6 parts we have done. So one question I took where sine inverse was written in terms of other inverse trigonometric functions. One question we have taken cos inverse written in terms of other trigonometric inverse trigonometric functions. And the third one was tan inverse written in terms of other. Mind you please, all these you can remember if you can. I'm not forcing, I'm just saying if you can remember them as formulae, but with the correct condition. Without that condition, these statements do not make any sense. I hope you understand it well. Please keep revising. They are extremely important formulae, so-called. If you wish, if you can do it. Keep practicing till I meet you next time. Till then, stay tuned. Thank you.